Let's go ahead and take a look at sodium sulfate. Again, we're referencing lecture 15x, page 2, descriptive inorganic chemistry. From our previous discussions, we have the dissolution of solid in the presence of water to give us the aquated species. We've seen that several times. And then we have the dissociation reaction. Again, keeping the polyatomics. Strong electrolyte, 100%. Gives us 2 sodium ions plus the sulfate. From our list that we made prior to spring break, that we said that sodium was a spectator ion because it's from a strong base. So sodium hydroxide being a strong base, then its conjugate sodium ion would be a very, very weak acid. From our list, we suggested that sulfate was a spectator. It's from sulfuric acid, which is a strong acid. So we'd expect the sulfate ion to be a very, very weak base. Is that really true? Let's take a closer look at that. Probably should label this as my dissociation. Sorry about that. Getting a little excited. Okay, so let's look at sulfate ion a little bit closer. You have another video on sodium as being a spectator, so we won't review that. So let's look at sodium, or sulfate, sorry. So sulfate could hydrolyze water, could give me hydroxide. Ooh. Hydrogen transfers. So this guy's acting like a Bronsted-Lowry acid. Good review. We're suggesting this is a Bronsted-Lowry base. So I do get my hydroxide, and then I get hydrogen sulfate ion, sometimes called bisulfate ion, especially in the medical field or pharmaceuticals. So let's go ahead and take a look at this guy. So we're looking at the KB, I'm going to call it KB2 because it's related to the Ka2 that is for the hydrogen sulfate, which the value is 0.012. So if we see a value of that, is that still considered a strong to moderate acid? Yes, it is. So we would suspect that this reaction, the hydrolysis reaction here, shouldn't go that big. Why? Let's take a look at our reasoning again. Ka2 equals Kw, but we're looking at Kb2. If Ka2 roughly is 10 to the minus 2, without regards to the figures, this is 10 to the minus 14. That means the Kb2 is 10 to the minus 10, which suggests that it's a very, very weak base. Oh. If we actually go on and do our calculations for our 1/10 molar solution of the sulfate ion, and using our more accurate Kb2 value based on similar figures, we'd find out that the pH of that 1/10 molar solution containing the sulfate ion will give us a pH of around 7.5, which is barely basic. So can we say that sulfate ion in solution is pretty close to being neutral? Yes, that's what's our argument. And our also argument is that it's a spectator.